A function is continuous at a point A if and only if, that means if this statement is true, then the function is continuous. If the function is continuous, then this statement is true. So it's a both backwards and forward statement. That's when we say if and only if. So a function is continuous if and only if the left side limit at that point, right side limit at that point, and the function's value at that point should be same. Now let's think about continuity. Continuity means if you put your finger on the left side of a point and the right side of a point, if you walk on the function, you should be smoothly cross between those 2 points. If you can smoothly cross, then that's a continuity. It's a general common sense continuity thing. So if the left side of that point limit, in this example, it would be P, and the right side of that point limit, in this example, it would be B. So limit x approaches to A from the left side is a B, and the limit x approaches to A from the right side is B, and f of A is also B. Remember, the curve is a combination of a bunch of points. So there's a point here, so hence f of A is B. So if all of these are same, f of x is continuous at x equals A. We learn 4 types of problems in continuity. First one is to verify if the function is continuous at a point. Second one is find the variables unknowns like A and B if the function is continuous. Third one is find a point of discontinuity if the function is given. And the fourth one is the types of discontinuity. So we are given a function here. We want to find out if the function is continuous at x equals 2. So what we are supposed to do, like we learned, function is continuous if and only if left side limit, right side limit, and the function's value should be the same. So they gave us here the function value is f of 2 already. It's a piecewise function. Left side and right side, we are supposed to use the same piece, because when x is not equals to 2, when x is approaching to left side means it's not exactly 2, but we are getting closer to 2. You are supposed to use this piece they gave you. And the same thing, limit x approaches to 2 from the right side, you use the same piece. Both sides, if we remember the method of evaluating these limits, it's a piecewise function. So we have to factor this piecewise function involving polynomials, indeterminate format. We cancel these 2, and we get a limit x approaches to 2. From the left side would be simply plugging it into leftover function. That gives you 4. Same way, if I find out limit x approaches to 2 from the right side, you do the exactly same, because we get indeterminate format, and the answer would be 4. F of 2 they gave us as 4 in the definition. Hence, limit x approaches to 2 from the right side is same as the left side and function's value. So f of x is continuous at x equals 2. This is called a continuity statement. and you must have this statement. If you don't have this statement, a lot of teachers like to deduct points because that's a very important statement you must write in your test. Let's look at another problem. We have to verify the continuity of this function at x equals 0 and x equals 4. So this is a piecewise function. We have three pieces here. First piece, second piece, and the third piece. So when we say verify the discontinuity or continuity at a point, you need to find left side limit, a right side limit, and the function's value. If you look at the function, x is less than 0 here, means left side of this one would be less than 0. You take first piece. When it says more than 0, you take the second piece because the domain here is more than 0. So here, left or right piece is the same thing. We have a formula for sin x over x. We learned in limits. The answer is 1. If I plug in for this function, 0 minus 0 minus 6 is negative 6. So you don't even have to verify this. You can just simply say this function is not continuous because left side limit is not same as the right side limit. So if I graph this, probably it's going to be something like 0 from the left side is somewhere ending up at 1. I don't know where it's going to be, but somewhere it's ending up at 1. And 0 from the right side, it's ending at negative 6. Of course, f of 0 is negative 6 as well because we are supposed to use the second piece. So hence this function, if you want to go from the left side of that point to right side of that point, I don't have smooth ride. I have to jump from one function to one piece to other piece. Hence this function is a discontinuous at x equals 0. Now let's check at x equals 4. So 4 from the left side, I take the second piece because that's a domain that says 4 less than 4. So x squared minus 2x minus 6. So plug in this value, 16 minus 8 minus 6, that is 2. 4 from the right side, you have to use this piece because 4 from the right side is more than 4. That's the third piece, which gives me 2. F of 4 also you substitute in the second piece because that's when equal sign shows on the problem. Hence, so here left side value, limit x approaches to 4 from the left side, right side f of 4 are same. So f of x is continuous at x equals 4. It fails to be continuous at x equals 0, but it is continuous at x equals 4.